Hello, my dear students. We've already completed exercise 12.1 and now we move on to few more questions from exercise 12.2. Please have a look. This is the sixth question from exercise 12.2. An umbrella is made by stitching 10 triangular pieces of cloth of two different colors. What you see in this image are 1, 2, 3, 4, 5, 5 triangular pieces. So this is the front view of the umbrella. The one behind, you will also have such 5 triangular pieces. They're of two different colors. One is blue and white. It could be any color. What you need to calculate here is how much cloth of each color is required for the umbrella. So let us take one triangular piece. Example, this blue triangle. The dimensions of the blue triangle is already mentioned. One of the side is 50, the other side is 20, and this side is also given as 50 centimeter. So we will calculate the area of this triangular piece using Heron's formula. You've already done this in the previous online class. You're aware that in a triangle, when the three sides are given and the height is not mentioned, you will find the area of the triangle by using Heron's formula. So it is done for you. Area of the triangle by Heron's formula. So first and foremost, you need to calculate S. S stands for the semi-perimeter. The semi-perimeter is sum of all the three sides divided by 2. So when you solve this, you get S as 60. Then you know the next step, you're finding the area of each triangular piece. Now you notice that each and every triangular piece, they all are of the same dimensions. So let us calculate this triangular piece, its area. Substitute these values. S is equal to 60. Now you are aware that A and B stand for the other two sides of the triangle. So you have A as, here it is taken as 20. Okay, the smallest value here is A. Then B is 50 and C is also 50. So you substitute the values. After you subtract, this is what you get. 60 into 40 into 10 into 10. You have seen how to solve this. I have mentioned this time and again. Do not multiply all the numbers. Calculating becomes a little difficult, so you're going to split it up. So 60 is split up as 6 into 10, 40 as 4 into 10, and these two 10 is written as it is. You take out the square root. So root 2 into root 2 is 2, and root 10 into 10 is 10. Again, you have root 10 into root 10, that is 10, because it becomes root 100 and square root of 100 is 10. And this root 6 is written as it is. So what you get here is 200 root 6 centimeters square. That means 200 root 6 centimeters square is the area of only one triangle. You have to calculate not the area of 10 triangular pieces, but you have to calculate 5 pieces of either pink color, here it is mentioned pink, or it could even be blue color like what is given out here, and 5 pieces of white color. So the cloth required for each piece is 200 root 6 centimeters square. So what will be the area of cloth required for 5 such triangles? Because if you look at the umbrella, there are 5 such blue triangles and 5 white triangles. Or you could say 5 pink triangles and 5 white triangles. Let's have a look at how much of meter square of cloth is required. Now in total there are 10 triangular pieces. So 5 pieces of pink or blue like I said, and 5 pieces of white. So 5 pink pieces are 5 into 200, or 5 blue pieces are 5 into 200, that is 1000 root 6 centimeters square. And 5 white pieces are 1000 root 6 centimeters square. So this is the area of cloth required to make an umbrella, which comprises of 5 white triangles and 5 pink triangles or blue triangles. Question number 7. This is quite an important question from this exercise. A kite in the shape of a square with diagonal 32 centimeter and an isosceles triangle at the base 8 centimeter and side 6 centimeter is to be made of 3 different shades. Okay, how much paper of each shade has been used in it? Now, which are the 3 different shades here? This triangle is in light blue, or you could call it gray. So this is one shade. This is another shade, part 2, and this is the third shade. They're all of different colors. So you need to calculate the area of part 1, area of part 2, and area of part 3. It is mentioned that this quadrilateral ABCD is a square. No doubt this whole figure is a kite, but this quadrilateral itself is a square. So let us calculate first the area of this shaded region, that is area of triangle BCD. Now that this quadrilateral is a square, use the properties of a square. You are aware that in a square, the diagonals bisect each other at right angles. That means angle CM is perpendicular to BD. So in triangle DCB, that is area of shade 1. Area of shade 1 and area of shade 2, both of them are equal because it is a square. Now, let us calculate first area of triangle BCD. Now, in this triangle BCD, BD is the base and CM is the height. So you don't have to use Heron's formula in this. We will use the formula area of this part 1 is half into base into height. That is half into dB into cm. Now, it is mentioned that one of the diagonal is 32 centimeter. So we have assumed dB to be 32. But since it is a square, the diagonals of the square will be equal. So AC is equal to BD equal to 32. So we know that the other diagonal CA will also be 32 centimeter. The diagonals of a square are equal. But the diagonals of a square, they also bisect each other. That means they cut each other into equal parts. So that means CM is equal to MA. So if the whole thing CA is 32 centimeter, what will be CM? It will be half of CA, that is 16. So area of shade 1 is half into base into height, half into 32 into 16. You get the answer as 256 centimeters square. So my dear students, the area of triangle BCD is 256 centimeters square. So we got the area of part 1. Now we need to find the area of part 2. You do not have to calculate the area once again. You just have to mention this, that area of shade 1 and area of shade 2 both are equal. So area of shade 2 is also 256 centimeters square. Now let us look into what is the area of shade 3 of this triangle. This triangle, if you notice, it's an isosceles triangle. Let's see how to calculate the area. In this triangle, two sides are 6 and 6 and the base is 8. Height is not mentioned. It makes more sense to use Heron's formula in this. So all the 3 sides are given. Before you use Heron's formula, you've learned you need to find the value of S. So we have calculated the semi-perimeter. Semi-perimeter comes to 10 centimeters. After finding out the semi-perimeter, let us calculate the area of shade 3 using Heron's formula. Note down the Heron's formula. Students, please make a note of this, as and when I'm reading out, I want you all to solve the questions. Area of triangle is, substitute the value, S is 10, A here is taken as 8, B is 6 and C is also 6. So these are the values of A, B and C. You have learned this in the earlier video lessons, how to take the value of A, B, and C. Find out their square roots. You get the answer as 8 root 5. Now 8 root 5. We have further solved the value. We have further solved this answer and found out what is the value of root 5. Now root 5, this is the calculation. I have mentioned this you have in the previous lesson. You have learned this also in lower class, how to find out the square root of this number 5 by division method. We have taken up to 3 decimals. 2 into 2 is 4, balance is 1. You multiply by 2, so you have to add 2 to it, so you get 4. You have to put in one more number out here. So if I put here 2, you get 42 into 2 is 84. If you take 43, you get a number greater than 100. Then when you subtract, you get 16. Bring down the other two zeros. Continue doing it up to 3 digits after the decimal. So the answer that you get here is 2.236. And when you multiply that by 8, this is the answer that you get. So this is the area of the isosceles triangle. So we have calculated the area of part 1, part 2, and the area of this isosceles triangle using Heron's formula. Let us look into another question. Question number 8 from exercise 12.2. This is a floral design which is made up of 16 tiles which are triangular, and they have given the dimensions of the triangle, that is 9, this is 9, this is 28, and this is 35. Then it is mentioned the one in blue is 35 here, 28 and 9. Find the cost of polishing the tiles at the rate of 50 paise per centimeter square. Now take one triangle. Take the triangle in white. If you look at each such petal or each such floral design, it is actually a quadrilateral. 1, 2, 3, 4. Okay, it's a four-sided figure. And there is a line in between which is dividing it into two such triangles. Now let us find the area of this triangle. So the dimensions are 9, 28 and 35. Find out the perimeter or calculate a plus b plus c divided by 2 and you get the semi-perimeter. After you get the semi-perimeter, I want you to calculate the area of the triangle using Heron's formula. By now you should be knowing how to do it because we have done many problems based on Heron's formula. So area of the triangular shaped tile. S is 36. This is the substitution and you get the area as 36 root 6 centimeter square. That means 36 root 6 centimeter square is this region in white, this white triangular region. Root 6, calculate the value of root 6. I want you to do this on your own. Answer is given here. Divide it, find it out up to 3 decimal places. Write down the value 2 digits after the decimal. So 36 into 2.45 centimeter square. This is the answer that you get approximately of a triangular shaped tile. That means of this one white tile, which is in the shape of a triangle. What have we to do further? Now this is the area of one such tile. How many such tiles do we have? 16. Let's count from here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 tiles. And it is each is divided into 2 parts. So 8 into 2, you have 16 such tiles. And each tile is in the shape of a triangle. So you get 16 into 88.2. This is the area of 16 such tiles. And the cost is 50 paise. So for 1411.2 centimeters square of tile, how much you will have to pay. So this is the value, 705 rupees and 60 paise. Students, I want you to take a notebook or your assignment sheet. Solution is there in front of you. I have explained it. I want you to solve it on your own and see whether you're getting the same answer. Please try to do it on your own because we have done many problems from Heron's formula. Okay, so with this, we complete few questions from exercise 12.2. These are some of the extra questions and I want you to solve this and do it for homework. ABC is a triangle and you have to find out the area of this region in yellow. So you find out the area of this region in white. It's a right angle triangle. So you need not use Heron's formula. Find out what is AB, okay, by Pythagoras theorem. Then use the formula half into product of the perpendicular sides. You will get the area of this triangle in white. After you get the area of the triangle in white, you find out the area of this complete triangle ABC using Heron's formula. The area of the larger triangle minus the area of the triangle in white, you will get the area of the shaded region. Likewise, I want you to even solve this question. Again, this is very similar to this. You will use, this is a right angle triangle, and here you will use Heron's formula. Add the two, you will get the area of the quadrilateral. Students, I expect you to do this homework. Okay, do it in your assignment sheet and go through all the problems that we have done. Okay, until then, bye bye.